Picture yourself standing beneath an infinite canvas of stars, each glimmering pinprick of light holding secrets beyond our comprehension. Now, imagine delving into that abyss, a place where time bends, light disappears, and colossal forces operate in ways that defy the very laws of physics as we know them. This is the universe, a realm so vast and enigmatic that even the most brilliant scientific minds are left grappling with more questions than answers. In this video, we're about to embark on an extraordinary journey across 20 cosmic mysteries that defy explanation. From regions of space eerily empty to powerful bursts of energy coming from billions of light years away, these phenomena are not just puzzles. They're keys that could unlock entirely new chapters in our understanding of reality itself. Space is not just an unexplored frontier, it is the ultimate frontier, a boundless expanse that humbles us, challenges us, and inspires us to keep asking the big questions. So get ready to dive deep into the unknown as we uncover the most baffling phenomena in the cosmos. Mysteries so profound they might just change the way you see the universe forever. Now turning to the first phenomenon, let us explore the enigmatic Great Attractor, a cosmic anomaly so powerful that it pulls entire galaxies, including our own Milky Way, toward it at breathtaking speeds. Imagine an unseen force drawing countless stars and galactic systems into its grasp, yet shrouded in a veil of mystery. Located in a region ominously named the Zone of Avoidance, this colossal entity is hidden behind dense cosmic dust and countless stars, making it nearly impossible for us to observe directly. Scientists theorize it could be composed of dark matter, the elusive substance that holds galaxies together, or perhaps a supermassive black hole on an unfathomable scale. Some even speculate it might be something far stranger, an entity that challenges everything we thought we knew about the universe. As we peer deeper into the cosmos with advanced technology, we are just beginning to scratch the surface of this puzzling force. What could be so overwhelmingly massive that it shifts the motion of entire galaxies? For now, the Great Attractor remains an unsolved cosmic riddle, quietly bending the very fabric of space and time. Moving forward, we venture into the staggering emptiness of the Boötes Void, an enormous region of space that defies comprehension. Spanning over 330 million light-years in diameter, this vast expanse has earned the chilling nickname, the Great Nothing. What makes this phenomenon so incredibly baffling is the sheer scarcity of galaxies within it. For perspective, a region of this size in the observable universe should typically contain thousands of galaxies, yet the Boötes Void houses only a handful, scattered like isolated islands in a dark cosmic ocean. Scientists are left grappling with questions about how such a void could form. One theory suggests primordial fluctuations in the early universe might have created this anomaly, leaving behind a region starved of matter during the cosmos formation. Others entertain more unconventional possibilities, including the idea that advanced alien civilizations could have engineered massive structures, clearing out the area for unknown purposes. Whatever the explanation, the silence of the Boötes Void is profoundly unsettling, as though the universe itself holds secrets it is not ready to reveal. This abyss of emptiness stands as a reminder of how little we truly understand about the cosmos and its origins. What lies hidden in this vast void, and why does it exist in such stark contrast to the rest of the universe? It is questions like these that keep scientists gazing upward, scanning the mysteries of space for answers. Now turning to the enigmatic world of fast radio bursts, we encounter one of the most bewildering phenomena ever detected in the cosmos. These intense, fleeting bursts of radio waves seem to arrive from galaxies billions of light-years away, lighting up our radio telescopes for mere milliseconds before vanishing without a trace. Their sheer power is staggering, releasing as much energy in that brief moment as our sun generates over several days. What makes fast radio bursts so perplexing is their unpredictability. They appear without warning, and despite years of research, scientists remain unsure of their origins. Could they be the result of catastrophic events such as colliding neutron stars or the collapse of massive black holes? Or are they caused by something even more exotic, perhaps phenomena we have yet to encounter or fully understand? Some theories even speculate that these bursts might be signals sent by advanced extraterrestrial civilizations attempting to communicate across the vastness of space. Recent breakthroughs have only deepened the mystery. In a few rare cases, astronomers have detected repeating fast radio bursts from the same sources, challenging previous assumptions that they were always caused by one-time cosmic explosions. Tracing these bursts back to their exact origins has proven immensely difficult, as their fleeting nature offers little time for detailed observations. This leaves us with one of the most pressing questions in modern astrophysics: what or who is creating these extraordinary signals? The answer to this puzzle could unlock entirely new realms of knowledge, changing our understanding of the universe forever. Now turning to the mysterious Tabby star, we find ourselves face to face with one of the most peculiar celestial objects ever observed. Officially known as KIC 8462852, this star captured scientific attention due to its bizarre and unpredictable dimming behavior. Unlike typical stars that might dim slightly due to planets passing in front of them, Tabby's star dims irregularly and sometimes by as much as 20%. A phenomenon far too extreme to be caused by any known planetary transits. This strange behavior has sparked a flurry of theories attempting to explain the mystery. One hypothesis suggests that a massive cloud of cometary debris is periodically blocking the star's light. Another posits the possibility of a swarm of orbiting planetary fragments left over from a catastrophic collision. However, neither fully accounts for the erratic and dramatic nature of the dimming. The most captivating theory involves the potential existence of an alien-built megastructure known as a Dyson sphere, designed to harness the star's energy. While there is no evidence to confirm this idea, its mere possibility has ignited imaginations worldwide. Astronomers have studied light curve data from Tabby's star extensively, which reveals unpredictable spikes and dips that defy all conventional explanations. Despite years of observation and analysis, no definitive answers have emerged, leaving Tabby's star as one of the biggest astrophysical mysteries of our time. Could its secret point to unknown cosmic processes, or might it be the result of something far more extraordinary? This enigma continues to challenge what we know about the universe, pushing the boundaries of scientific exploration and curiosity. Moving forward, we arrive at one of the most profound and enduring questions in cosmology: the true shape of the universe. For decades, scientists have debated whether our cosmos is flat like an endless plane, spherical like a closed bubble, or saddle-shaped, curving outward infinitely. Each of these possibilities offers a radically different view of our universe's structure and destiny. Current observations, including studies of the cosmic microwave background radiation, suggest that the universe is incredibly close to being flat. However, the margin for error leaves room for doubt, and alternative theories challenge this conclusion. For instance, a spherical universe implies that space itself would eventually loop back on itself, making it finite yet unbounded, like the surface of a sphere. On the other hand, a saddle-shaped universe would curve outward forever, creating a geometry where parallel lines diverge rather than meet. Despite extensive measurements, the evidence remains inconclusive and sometimes contradictory, leaving scientists uncertain about which model truly reflects reality. Adding complexity, the role of dark energy and its influence on cosmic expansion further complicates these theories. Could dark energy be distorting our observations, masking the universe's true geometry? The mystery of the universe's shape is not just theoretical but deeply tied to questions about its origins, evolution, and ultimate fate. Whether it will expand forever, collapse back into a singularity, or reach a stable equilibrium may depend entirely on its geometry. As researchers push the limits of observational technology, they hope to uncover the answers, but for now, the shape of the universe remains one of science's greatest unanswered riddles. Now turning to the next enigma, we encounter the cosmic microwave background cold spot, a vast and perplexing region in the afterglow of the Big Bang that has left scientists scratching their heads. This area, appearing significantly colder than the surrounding cosmic microwave background radiation, defies the expectations set by standard models of cosmic evolution. Spanning over 1 billion light-years, this anomaly cannot simply be brushed off as a measurement error. Instead, it raises profound questions about the structure and history of our universe. One of the proposed explanations involves quantum fluctuations during the universe's infancy that may have left imprints on the cosmic microwave background. Another possibility is the existence of a colossal supervoid, a region of space with far fewer galaxies and less matter than usual. Such a void could alter the path of light traveling through it, creating the illusion of a cold spot. However, what makes this phenomenon even more intriguing is the speculation that it could be evidence of something far more radical, like a collision between our universe and another in a so-called multiverse scenario. This idea suggests the cold spot might be a scar, a place where two universes brushed against each other in their formative stages. Each of these theories, while fascinating, remains without conclusive proof as scientists continue to gather data in search of a definitive answer. Could this cold spot be a mere statistical fluke, or is it a gateway to understanding deeper cosmic truths? For now, it remains a striking reminder of how much we still have to learn about the vast and mysterious cosmos that surrounds us. Now turning to the next cosmic mystery, we dive into the enigmatic realm of dark matter. This invisible substance, making up approximately 27% of the universe, is one of the greatest puzzles confronting modern science. Despite its significant presence, dark matter neither emits nor reflects light, rendering it completely undetectable by conventional telescopes. Yet, its existence is undeniable due to the gravitational effects it imposes on visible matter. For instance, galaxies spin at speeds that defy the amount of detectable mass within them, behaving as though an unseen force is holding them together. This unseen force is attributed to dark matter, but what is it made of? Scientists have proposed it could be exotic particles unlike anything we have encountered, or some entirely new aspect of physics beyond our current understanding. The implications are profound, as this mysterious substance acts as the cosmic glue binding galaxies and influencing the universe's large-scale structure. Without dark matter, our universe as we know it would not exist, and yet years of research have left us with more questions than answers. Why can we observe its gravitational pull but not detect it directly? Is it made of particles, or are we missing something even more fundamental? Scientists are tirelessly working to unlock the secrets of dark matter, using advanced experiments and instruments, but for now, much of it remains hidden, a shadowy presence in the fabric of the cosmos, daring humanity to uncover its true nature. Moving forward, we encounter an even greater cosmic enigma: dark energy. This mysterious force is thought to comprise an astounding 68% of the universe, yet its nature eludes even the brightest scientific minds. Unlike dark matter, which exerts a gravitational pull to hold structures together, dark energy is believed to do quite the opposite. It drives the expansion of the universe at an accelerating pace. Imagine this: instead of the universe gradually slowing its expansion over time due to gravity, it is speeding up as though an invisible hand is pushing galaxies farther and farther apart. But what exactly is dark energy? Is it a new form of energy woven into the very fabric of space itself, or perhaps a property of space that emerges from the quantum realm? Some theories suggest it may be linked to the cosmological constant, an idea introduced by Albert Einstein before he famously dismissed it as his biggest blunder. Others propose entirely new dimensions of physics we have not yet begun to comprehend. The challenge lies in its detection. While its effects on the universe are visible on the grandest scale, dark energy remains undetectable in laboratories. Sophisticated experiments and cutting-edge telescopes are striving to measure its influence with greater precision, but the answers remain frustratingly out of reach. Dark energy is not just a mystery, it is a profound question that reshapes our understanding of the universe and its ultimate fate. Could this force continue to stretch the cosmos indefinitely, or will it one day reveal secrets that transform our grasp of reality itself? For now, it is a silent, unseen force driving a cosmic expansion that keeps scientists and all of humanity searching for answers. With the next phase of the journey in sight, we arrive at the captivating mystery of rogue planets, celestial bodies adrift in the darkness of space, completely untethered to any star. Unlike the planets in our solar system, which gracefully orbit the sun, rogue planets wander aimlessly through the void, seemingly cast out of their original planetary systems. Their discovery has been nothing short of incredible, achieved through a phenomenon known as gravitational microlensing. This method involves detecting the slight bending of light from a distant star as a rogue planet passes in front of it, a fleeting yet revealing moment that hints at the existence of these solitary travelers. But here's the baffling part. How do these planets end up wandering alone in the vastness of space? Some scientists theorize that they could have been violently ejected from their original systems during chaotic planetary migrations or gravitational interactions with other massive objects. Others suggest they may have formed in isolation, never bound to a star in the first place. Regardless of their origin, the very existence of rogue planets challenges our understanding of planetary formation and dynamics. What's even more enigmatic is the sheer number of them. Studies suggest there may be more rogue planets in our galaxy than stars, a revelation that redefines the scale of our cosmic neighborhood. Imagine the desolate beauty of these worlds drifting through the cold, silent expanse of interstellar space, illuminated only by the faint glow of distant stars. Could some of these lonely planets harbor underground oceans or even primitive forms of life, shielded from the harshness of the cosmos? The possibilities are as thrilling as they are mysterious, leaving scientists and dreamers alike craving to uncover more about these solitary wanderers. Moving forward, let us delve into one of the most perplexing enigmas in astrophysics, the case of the missing baryonic matter. Baryonic matter, which consists of the familiar building blocks of the universe like protons, neutrons, and electrons, is what makes up everything we can see, from stars and planets to galaxies and even ourselves. However, astonishingly, scientists estimate that nearly half of this normal matter seems to have vanished without a trace. This isn't dark matter we're talking about, the mysterious and invisible substance that dominates the cosmos. This is regular matter, the kind we know exists, yet it remains unaccounted for. So, where did it go? Astronomers have spent decades hunting for this elusive matter, scouring the farthest reaches of the universe for clues. One compelling theory suggests that it may be hiding in vast intergalactic gas clouds, tenuous threads of hot, diffuse gas stretched out across the cosmos like an almost invisible spider web connecting galaxies. These clouds, known as the warm-hot intergalactic medium, or WIM, might hold the key. They are incredibly faint and difficult to detect, but some recent observations using powerful space telescopes have hinted at their presence. If these gas clouds do contain the missing baryonic matter, it would drastically reshape our understanding of the universe's composition and structure. But even with these promising leads, the mystery is far from solved, leaving the scientific community grappling with more questions than answers. Could this missing matter have implications for how galaxies form and evolve? Does it challenge our fundamental models of how the universe works? the search for answers continues, and with every new discovery, we inch closer to unlocking one of the universe's most profound secrets. As we drift further into the unknown, our next puzzle unveils a cosmic visitor that defied explanation, the enigmatic object known as Oumuamua. Now turning to one of the most intriguing cosmic visitors ever observed, let us explore the mystery of Oumuamua, a cigar-shaped object that passed through our solar system in the year 2017. Initially spotted by astronomers in Hawaii, Oumuamua, which means scout or messenger in the Hawaiian language, immediately captured global attention. Why? Because it was the very first interstellar object ever detected in our solar system, and it didn't behave like anything we had seen before. At first, scientists believed it to be an asteroid, but its elongated, almost perfectly cylindrical shape and lack of a visible tail ruled out typical asteroid behavior. Then came the idea that it might be a comet, but it displayed no signs of outgassing, the process responsible for producing a comet's iconic glowing tail. Things became even stranger when researchers noticed that Oumuamua exhibited a slight but unexpected acceleration as it exited our solar system. This wasn't due to the gravitational pull of any nearby body, leading to speculation that something else, something more mysterious, was propelling it. Could it be a chunk of hydrogen ice sublimating, creating thrust? Maybe. Or could it be light pressure, a phenomenon where sunlight itself generates a gentle push? Perhaps, but what truly set imaginations alight was the possibility proposed by some scientists that Oumuamua might be an alien probe, a piece of advanced technology sent by an extraterrestrial civilization to survey distant star systems. While most in the scientific community lean toward natural explanations, the absence of definitive evidence has left the door open to endless theories, making Oumuamua one of the greatest cosmic puzzles of our time. With its origins and purpose still shrouded in mystery, Oumuamua has reminded us just how much we have yet to uncover about the universe. As its secrets remain locked away in the depths of space, we now turn our attention to another unsolved question. How do colossal magnetic fields take shape across the vast expanse of the cosmos? Now turning to the enigma of magnetic fields in space, we encounter a phenomenon that permeates galaxies, stars, and even intergalactic space, yet remains one of the least understood aspects of the cosmos. Magnetic fields are invisible forces that influence charged particles and cosmic structures. But what baffles scientists is their immense scale and surprising uniformity across vast regions of space. For instance, entire galaxies are often embedded with magnetic fields that stretch tens of thousands of light years, displaying a level of coherence that defies expectations given the chaotic nature of the universe. Even more puzzling is the presence of these fields in the seemingly empty voids between galaxies, where there is hardly any matter for them to interact with or derive their energy from. While magnetic fields are well documented on Earth and in stars like our Sun, their cosmic counterparts are astonishingly larger and stronger than what current theories can fully explain. One hypothesis suggests that these fields may have originated from tiny seed fields, weak magnetic traces left over from the early universe, that were then amplified over billions of years by the movement of plasma and the rotation of galaxies. However, this still does not account for the initial creation of these seed fields in the first place. Could they be a relic of the Big Bang, tangled within the primordial plasma? Or could they have emerged through unknown processes tied to dark matter or other exotic phenomena? Another layer of mystery lies in their potential purpose within the cosmic order. Magnetic fields appear to play a crucial role in shaping galaxy formation, guiding charged particles, and even influencing star birth within stellar nurseries, but we are far from understanding the full extent of their influence. Recent observations using advanced radio telescopes, such as those part of the Square Kilometre Array project, aim to map and study these elusive fields in unprecedented detail. Yet, despite modern technology, the origin, evolution, and ultimate role of magnetic fields in the universe remain unanswered. It's a humbling reminder of how much lies beyond our grasp in the cosmic puzzle. With that, let us shift our gaze to another mind-bending phenomenon: how galaxies themselves engage in a cosmic dance of destruction and creation through the process of galactic cannibalism. Moving forward to the phenomenon of galactic cannibalism, we delve into an extraordinary cosmic process where larger galaxies consume their smaller counterparts, dramatically reshaping their structures in the process. This isn't just a rare event, rather, it is believed to be a fundamental mechanism in the evolution of galaxies, including our very own Milky Way. Through this process, galaxies grow and transform, acquiring new stars, gas, and other materials that can ignite waves of star formation or even trigger the growth of supermassive black holes at their centers. But while the concept of galactic cannibalism is well documented, many questions remain unanswered. How often does this happen on a universal scale? Does this cosmic feast primarily occur in the early stages of the universe, or is it still an ongoing process shaping the galaxies we see today? Even more intriguing is the role these mergers play in forming some of the universe's most massive and unique galactic structures, such as elliptical galaxies, which are thought to be the end products of numerous ancient collisions. One of the most studied examples is the Andromeda Galaxy, which is on a slow-motion collision course with our own galaxy. In roughly 4 billion years, the two are expected to merge in a spectacular event that will completely transform their shapes and possibly give birth to a new galaxy. Simulations of such mergers show intricate gravitational interactions, where stars and other materials are flung into complex orbits, creating stunning tidal streams that stretch across the cosmos. But what is perhaps most mystifying is the exact physics behind these collisions. How do the forces at play govern which galaxies survive, which are absorbed, and which are left irreparably disrupted? And what determines the ultimate fate of the stars, black holes, and gas clouds involved? To unravel these mysteries, astronomers use cutting-edge technology such as high-resolution telescopes and advanced computer simulations, which allow us to recreate these galactic collisions on a digital stage. Yet despite these advancements, there is still much to learn about what happens to the smaller galaxies caught in these cosmic dances. Do they simply vanish into the larger galaxy, or do they leave behind faint, traceable signatures that hint at their once independent existence? Galactic cannibalism is not just a story of destruction. It is also a story of creation and renewal, as these events often lead to the birth of new stars and the redistribution of cosmic material across vast distances. It is a testament to the dynamic, ever-changing nature of the universe, where even destruction serves a greater purpose in the grand cosmic design. And as we consider this awe-inspiring process, our journey shifts once again to a single baffling moment in history that has had scientists scratching their heads for decades: the infamous WOW signal. Now turning to the infamous WOW signal, we delve into one of the most tantalizing mysteries in the search for extraterrestrial intelligence. Detected in the summer of 1977 by a radio telescope known as the Big Ear at Ohio State University, this brief but extraordinary signal left scientists stunned. For just 72 seconds, the telescope captured a powerful burst of radio waves originating from the constellation Sagittarius, unlike anything previously recorded. What made this signal so remarkable was its intensity and specific frequency, both of which aligned with characteristics scientists theorize might be used by advanced civilizations to communicate. The astronomer who discovered it, Jerry Amon, was so astonished by its clarity and strength that he circled the data on the printout and wrote a single word in the margin while giving the phenomenon its memorable name. What sets the WOW signal apart is that it has never been detected again, despite decades of follow-up observations and advancements in radio astronomy. This singular occurrence has led to a flurry of questions and theories. Could it have been a transmission from an intelligent extraterrestrial source, perhaps directed at Earth but sent from an unimaginably distant world? Or was it a natural cosmic event, such as emissions from a star, planet, or even a peculiar type of celestial object we have yet to identify? Adding to the intrigue is the fact that the frequency of the signal, around 1420 MHz, happens to be in a part of the radio spectrum that is naturally quiet, making it less likely to be drowned out by cosmic background noise. Some speculate that this very frequency, associated with hydrogen, the most abundant element in the universe, might be intentionally chosen by intelligent beings as a universal hailing frequency. However, the lack of a repeat detection complicates the mystery. If it was indeed a message from an intelligent source, why did it stop? Could it have been a one-time transmission, or might it be on a cycle far beyond our current capacity to predict? Others propose that the signal could have been a result of a rare cosmic alignment or even interference from an Earth-based source, although extensive analyses have ruled out the latter. Despite exhaustive efforts to solve this enigma, including retargeting the same region of space with more sensitive equipment, the WOW signal remains unique, a brief whisper from the cosmos that has yet to reveal its secrets. As we ponder this mysterious signal, it encapsulates the immense challenge of searching for extraterrestrial intelligence in a vast and largely unknown universe. It reminds us that even a fleeting anomaly can ignite decades of scientific curiosity and debate. And while the WOW signal's origin remains an enigma, it continues to inspire humanity's quest to answer one of the most profound questions of all time: are we truly alone? With this enduring mystery in mind, we now shift to another fascinating cosmic puzzle: the existence of ultra-diffuse galaxies that defy our understanding of galactic formation and structure. Now turning to the realm of ultra-diffuse galaxies, we encounter a phenomenon that redefines what we thought we knew about galactic formation. These ghostly galaxies are vast in size, sometimes rivaling the Milky Way, yet their density is so incredibly low that they are nearly invisible against the backdrop of space. Imagine a galaxy so faint and scattered that it appears more like a wisp of cosmic fog than a dense cluster of stars. What makes these galaxies particularly mysterious is the extreme contrast in their compositions. Some ultra-diffuse galaxies seem to be brimming with dark matter, the unseen substance that is believed to hold galaxies together through its gravitational pull. In these cases, galaxies that are barely detectable still manage to maintain their structure in ways that shouldn't be possible without an abundance of this enigmatic matter. However, the puzzle deepens when we discover that other ultra-diffuse galaxies appear to have almost no dark matter at all. This defies our fundamental understanding of galaxy formation, which relies heavily on the presence of dark matter as the cosmic scaffolding holding stars and gas in place. How can such a large and fragile structure exist without this critical ingredient? Theories abound, ranging from the idea that these galaxies were stripped of their dark matter through past interactions with larger, more dominant galaxies, to the possibility that they formed in ways yet unknown to science. Adding to the enigma, their very existence challenges the models we use to simulate the evolution of galaxies. How can we account for such extremes on both ends of the spectrum, galaxies teeming with dark matter versus those entirely devoid of it? Are ultra-diffuse galaxies evidence of an alternative formation process, or do they point to gaps in our current understanding of dark matter itself? These spectral apparitions scattered across the cosmos continue to raise more questions than answers, making them a compelling target for future observations and research. As we scrutinize these faint cosmic anomalies, ultra-diffuse galaxies remind us that the universe often operates in ways that resist human comprehension. Their peculiar nature not only challenges the boundaries of our scientific knowledge, but also provides a humbling perspective on how much remains to be discovered about the fabric of the cosmos. As we drift through the mysteries of these curious formations, our journey now brings us to the explosive marvel of gamma-ray bursts, the most powerful and fleeting events in the universe. Now turning to the explosive marvel of gamma-ray bursts, we find ourselves in the presence of the universe's most energetic and mystifying events. These staggering explosions release more energy in a matter of seconds than an entire star might produce over its entire lifetime. Imagine an immense, blinding flash of energy tearing through space, capable of briefly outshining everything in its galaxy. Gamma-ray bursts not only command attention for their sheer power, but also for the enigma surrounding their origins. Scientists believe that these bursts may be triggered by the dramatic collapse of massive stars, where a dying star's core implodes and forms a black hole, unleashing intense jets of radiation. Another leading theory suggests that such bursts could emerge from the violent collision of neutron stars, the ultra-dense remnants left behind after a star has gone supernova. Despite these theories, much about gamma-ray bursts remains shrouded in mystery, especially their unpredictability. They can occur anywhere in the universe, and their fleeting nature, they last anywhere from a fraction of a second to a few minutes, makes them incredibly difficult to study. Even with advanced technology, pinpointing their exact locations and origins is like trying to find a single spark in an endless sea of darkness. Adding to the intrigue, gamma-ray bursts come in two distinct varieties: short bursts that last less than 2 seconds and long bursts that can persist for several minutes. Each type might have entirely different causes, compounding the challenge of understanding these cosmic firework displays. What makes gamma-ray bursts even more confounding is their incredible reach. The radiation they emit travels across billions of light years, sometimes reaching us from the farthest corners of the known universe. By the time these bursts are detected on Earth, they have already traversed vast stretches of space, carrying with them secrets about the conditions of the early universe. Scientists hope that studying these enigmatic events could shed light on everything from the formation of black holes to the distribution of heavy elements like gold and platinum, which are believed to be forged in such extreme cosmic environments. Yet for all the knowledge gained, gamma-ray bursts remain one of the universe's unsolved riddles. Are there other, entirely unknown phenomena responsible for these bursts? Could they be linked to processes we've yet to discover, or do they hint at flaws in our understanding of stellar evolution? As we ponder the fleeting yet staggering brilliance of gamma-ray bursts, we are reminded of how much about the cosmos continues to elude us. From these dazzling explosions that illuminate galaxies for mere moments, our journey now shifts to a paradox that questions the very likelihood of life elsewhere in the universe, the Fermi paradox. As the next challenge unfolds, we confront one of the most profound and unsettling questions in the realm of cosmic exploration, the Fermi paradox. In a universe so unfathomably vast, with billions of galaxies, each containing billions of stars and likely even more planets, why have we yet to detect any signs of intelligent alien life? This paradox stands as a glaring contradiction to the high probability of alien civilizations predicted by statistical models like the Drake equation. Named after the physicist Enrico Fermi, it forces humanity to grapple with the eerie silence of the cosmos, despite the staggering numbers that suggest we should not be alone. The Drake equation, a formula designed to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way, takes into account factors like the number of stars, the fraction with planets, and the likelihood of those planets supporting life. While its exact figures are debated, most calculations imply that intelligent life should exist in multiple places across the galaxy. Yet all we encounter is a deafening silence. This silence raises unsettling possibilities. Is intelligent life incredibly rare, emerging only under precise and improbable conditions? Or does it destroy itself before achieving interstellar communication, hinting at the ominous concept known as the Great Filter? The Great Filter theory suggests that at some point in a civilization's development, there lies a nearly insurmountable barrier that prevents it from thriving or communicating across the stars. This filter might occur at the beginning of life, making the emergence of even simple organisms extraordinarily unlikely. Alternatively, it could strike later, perhaps after civilizations develop advanced technology but fail to avoid self-destruction through war, environmental collapse, or other catastrophic events. If the Great Filter lies ahead of humanity, it poses a dire warning about our own survival. Equally thought-provoking is the possibility that alien civilizations exist, but for reasons beyond our understanding, they choose not to communicate with us. Some theorists speculate that extraterrestrial life may observe a cosmic version of hands-off ethics, avoiding contact with less advanced species like ours to allow natural development. Others consider the darker possibility that advanced civilizations are actively avoiding detection, perhaps out of fear of hostile counterparts. Still, some argue that we may be looking at the wrong signals or using the wrong methods. Our searches often rely on detecting radio waves or other forms of communication similar to our own. But what if aliens use entirely different technologies or communication methods that we cannot yet comprehend? There is even the disquieting idea that advanced civilizations could exist in forms so unrecognizable to us, like artificial intelligence or even as energy-based entities, that we wouldn't even know how to identify them. The Fermi paradox does more than question the absence of extraterrestrial life. It challenges us to reflect on the fragility and rarity of our own existence. Are we truly the only intelligent beings to emerge, or are we simply not yet capable of seeing or understanding others? As we ponder this cosmic mystery, it serves as both a humbling reminder of our limited perspective and an invitation to keep exploring, questioning, and pushing the boundaries of what we know. From this thought-provoking paradox, we transition to a puzzling phenomenon that once left even seasoned scientists scratching their heads: the Pioneer anomaly. Now turning to the next enigma, we delve into the mystery of the Pioneer anomaly, a phenomenon that left scientists baffled as they tracked the journeys of two spacecraft, Pioneer 10 and Pioneer 11, into the far reaches of our solar system. Launched in the early 1970s, these spacecraft were designed to venture beyond the planets and provide humanity with its first glimpses of the outer solar system. While they accomplished groundbreaking observations of Jupiter and Saturn, their missions took an unexpected turn as they drifted away from the Sun. As the Pioneers continued their trajectories, scientists noticed something peculiar. Both spacecraft displayed a small but consistent deviation from their predicted paths, appearing to slow down as if an unseen force was tugging on them. This anomaly was subtle, with the deceleration amounting to less than 1/10 billionth of Earth's gravity, yet it was enough to spark intense debate and investigation. Could it be a gravitational anomaly, perhaps from an unknown celestial body lurking in the darkness? Or was it a clue to some hidden aspect of physics that we have yet to uncover? One theory suggested that the anomaly might be caused by heat radiating unevenly from the spacecraft. The Pioneers relied on radioisotope thermoelectric generators for power, which released heat as part of their normal function. If this heat radiated asymmetrically, it might have created a tiny push, altering the spacecraft's trajectory. While this explanation gained traction among scientists, it has not been universally accepted, leaving room for further questions. Others speculated about the potential involvement of dark matter, an invisible substance believed to make up a significant portion of the universe's mass. Could the Pioneer spacecraft have encountered regions of space with higher concentrations of dark matter, subtly altering their movements? While this idea is intriguing, no direct evidence has been found to support it. Then there is the possibility that the anomaly hints at limitations in our current understanding of physics. Einstein's theory of general relativity governs our understanding of gravity and motion on cosmic scales, But what if there are additional forces or principles at play in the vast expanse of space? The Pioneer anomaly has led some researchers to question whether our fundamental models of the universe might need revision. Despite exhaustive studies, the true cause of the Pioneer anomaly remains a topic of debate. It represents a profound reminder of how much we have yet to learn about the universe and how even the smallest irregularities have the power to challenge established scientific paradigms. From this enduring puzzle, we now turn to a truly unique and visually stunning mystery, Saturn's hexagonal storm. Now turning to Saturn's north pole, we encounter one of the solar system's most mesmerizing and perplexing phenomena, the hexagonal storm. Unlike anything observed on other planets, this massive, six-sided weather system spans over 18,000 miles in diameter, large enough to fit almost 4 Earths within its bounds. First discovered by the Voyager spacecraft in the early 1980s and later studied in greater detail by NASA Cassini mission, this geometric marvel has left scientists both captivated and baffled. How could a storm take on such a precise and sustained hexagonal shape in the chaotic dynamics of a planet's atmosphere? The storm's distinct edges are defined by high-speed jet streams, with winds roaring at nearly 300 miles per hour, yet the mechanism behind this extraordinary structure remains an enduring mystery. One popular hypothesis suggests that the shape could result from a standing wave pattern in Saturn's atmosphere. Essentially, this would mean that differences in wind speeds at certain latitudes interact to create a stable, geometric standing wave, much like the patterns seen in vibrating fluids or rotating systems on Earth. However, replicating such a phenomenon artificially, even in controlled simulations, has proven incredibly challenging. Adding to the enigma is the storm's remarkable stability. For over 40 years since its discovery, the hexagon has remained firmly in place, even as other atmospheric features on Saturn have come and gone. This level of consistency defies what we know about planetary weather systems, which are often turbulent and ever-changing. Why does this storm endure when similar phenomena elsewhere dissipate much more quickly? Intriguingly, the hexagonal pattern isn't just confined to the surface clouds. Atmospheric readings from Cassini revealed that the shape extends deep into Saturn's atmosphere, possibly hinting at complex processes occurring far below the visible layers. Yet, despite all our data, scientists are still wrestling with unanswered questions. Could this unique geometry be linked to Saturn's rapid rotation or its internal heat distribution? Or does it represent some entirely unknown atmospheric mechanism that exists only on gas giants like Saturn? Further mysteries arise when considering Saturn's south pole, which hosts a massive storm as well, though this one is a conventional circular cyclone, lacking the stunning, angular symmetry of its northern counterpart. Why is such a feature exclusive to the North Pole? Is it due to differences in hemisphere temperatures, solar exposure, or perhaps the alignment of Saturn's magnetic field? These questions continue to drive research as scientists analyze every detail captured by the Cassini probe to unravel this cosmic enigma. The hexagonal storm on Saturn challenges our understanding of atmospheric dynamics, offering a vivid reminder of the uncharted complexities in otherworldly weather. From this geometric masterpiece, we now venture further outward to confront the ultimate boundary of human observation, the edge of the observable universe. Now turning to the edge of the observable universe, we find ourselves peering into the outermost limits of human understanding. This is the farthest distance light has traveled since the beginning of time, roughly 13 billion light-years away, giving us a snapshot of the cosmos as it existed mere moments after the Big Bang. Beyond this boundary lies a realm shrouded in mystery, regions of the universe so far removed that their light has not yet reached us, nor perhaps ever will. But what exactly is out there beyond the cosmic horizon? Is it the same as what we can observe, or does it hold entirely different structures and phenomena that defy our comprehension? One prevailing question is whether the universe itself is finite or infinite in size. If the universe is infinite, then the observable part, the region we can see, is just a tiny fragment of an unimaginably vast expanse filled with countless galaxies, stars, and perhaps even civilizations beyond our reach. On the other hand, if the universe is finite, it raises the possibility that it could loop back on itself like a three-dimensional sphere, meaning a sufficiently long journey would bring you back to your starting point. This would also imply that there is a definitive edge to space, though not necessarily in the way we understand physical boundaries. Then, there are theories suggesting that what lies beyond the observable universe could be radically different from what we know. Some scientists propose that the cosmos might be heterogeneous on larger scales, with regions dominated by entirely different physical laws or constants. This could mean that the universe, as we experience it, is just one bubble within a grander multiverse, an infinite sea of bubble universes, each with its own unique properties. Such possibilities stretch the limits of imagination and challenge the very frameworks of modern cosmology. Adding to the intrigue is the cosmic microwave background, the faint afterglow of the Big Bang, which acts like a map of the universe's early conditions. This radiation provides tantalizing clues about what might exist just beyond what we can see, as subtle anomalies in its patterns hint at the potential influence of unseen regions. These deviations raise questions about whether our observable universe was shaped by interactions with other cosmic domains, potentially illuminating evidence of neighboring universes within a multiverse framework. Of course, the greatest limitation in uncovering what lies beyond the edge of the observable universe is the nature of light and time itself. Because the speed of light is finite, we can only see objects whose light has had enough time to reach us. As the universe expands, distant galaxies continue to move further away, meaning some will eventually cross the cosmic horizon and slip from view forever. This creates a dynamic, constantly shifting boundary that forever limits what humanity can explore. Despite our advanced telescopes and technologies, we may never gain a complete picture of the universe's true size or structure. The edge of the observable universe reminds us of our significance or insignificance within the cosmic tapestry. It represents the ultimate frontier, a boundary that challenges our understanding of physics, time, and existence itself. As humbling as it is, this horizon fuels our relentless curiosity, propelling us toward deeper investigations and more ambitious explorations. From pondering the vast unknowns beyond the cosmic horizon, we now turn our attention to uncovering the interconnected mysteries that bind these phenomena together. As the next phase of the journey unfolds, we begin to weave together the threads of these cosmic mysteries, uncovering how they might be interconnected in ways that deepen the enigma of our universe. Consider the role of dark matter and dark energy, the unseen forces that dominate the cosmos. Dark matter, though invisible, exerts a gravitational influence that holds galaxies together, while dark energy drives the universe's accelerating expansion. These two phenomena, though seemingly at odds, shape the very fabric of the universe and may be key to understanding anomalies like the Boötes Void, a region of space conspicuously lacking in galaxies. Could the void's eerie emptiness be a clue to how dark matter and energy interplay across cosmic scales? Or might it hint at regions where these forces behave differently, challenging our current models? The missing baryonic matter mystery further complicates this puzzle. Ordinary matter, the kind that forms stars, planets, and all visible structures, should be far more abundant based on our understanding of the early universe. Yet, astronomers have identified only a fraction of it, speculating that the rest resides in elusive intergalactic gas clouds or other unobservable forms. Could this missing matter be subtly linked to phenomena like rogue planets or ultra-diffuse galaxies, whose existence also defies traditional explanations? Perhaps these scattered, low-density structures are remnants of a larger, hidden process shaped by the same forces behind dark energy's expansion or the gravitational pull of dark matter. Then there's the question of whether these mysteries point toward interactions on a grander scale, possibly across multiple universes. The cold spot in the cosmic microwave background and the peculiar behaviors of objects like Oumuamua might suggest influences from beyond our universe, interactions that ripple across dimensions and alter the structures we observe. What if the cosmic puzzles we struggle to solve are connected not just by the laws of physics within our universe, but by forces or phenomena that transcend it entirely? The interconnectedness of these mysteries forms an intricate web of unanswered questions, each thread pulling us closer to the edge of what we know while unraveling the limits of human understanding. From this intricate network, we shift our focus toward exploring the potential that future technological innovations hold in unraveling these cosmic enigmas. With the next phase of the journey in sight, we turn our attention to the incredible potential that lies in future space exploration, a frontier driven by humanity's collective desire to solve these cosmic mysteries. Take the James Webb Space Telescope, for instance, the most advanced observatory ever built. Its unparalleled ability to peer deeper into the universe than any of its predecessors offers scientists a chance to uncover clues about phenomena like the Great Attractor or the cold spot in the cosmic microwave background. By capturing light from the earliest galaxies, it could provide insights into how the universe evolved and whether anomalies like these were shaped by events in its infancy. Beyond telescopes, there are initiatives focused on interstellar objects such as Oumuamua, which passed through our solar system and left behind more questions than answers. Future missions aim to intercept or study such objects more closely, potentially revealing whether their origins are natural or something far more extraordinary. Similarly, the search for rogue planets drifting between stars could unlock hidden chapters of planetary formation and provide vital context for understanding the abundance of planets across the universe. Technological innovations aren't just confined to observation. Advances in particle physics and laboratory experiments here on Earth hold the promise of shedding light on the enigmatic forces of dark matter and dark energy. By recreating conditions akin to the early universe or simulating cosmic interactions, researchers hope to unlock the secrets of these unseen powers that govern the cosmos. The mysteries of space also push us to think beyond our traditional boundaries. Concepts like the creation of new propulsion systems, allowing spacecraft to travel faster and venture farther, are no longer confined to science fiction. These developments are essential if we are to explore regions of space that hold answers to questions about the missing baryonic matter or ultra-diffuse galaxies. With the potential to travel interstellar distances, humanity might one day solve some of the universe's greatest riddles up close. As these innovations unfold, they not only promise to answer age-old questions but also ignite new ones, inspiring the next generation of explorers and scientists. The tools we create today are paving the way for a future where the unknown becomes known, where we may finally find our place in the grand cosmic tapestry. Moving forward, it is equally fascinating to consider whether these discoveries could point to something even more profound, the possibility of extraterrestrial connections woven into the very fabric of these mysteries. Now turning to the intriguing possibility of extraterrestrial connections, some of these baffling phenomena seem to tantalize us with hints of alien life. Take the WOW signal, a mysterious burst of radio energy detected in the late 1970s. Its intensity and unique frequency, matched with the absence of any repeating signals, have fueled speculation that it may have originated from an advanced extraterrestrial civilization attempting to communicate. Though efforts to detect a similar signal have come up empty, the question remains, could an intelligent alien species be behind this anomaly? Then there is the enigmatic Great Attractor, whose immense gravitational pull drags entire galaxies toward it, including our own Milky Way. While theories of dark matter and supermassive black holes dominate scientific debates, some have dared to ask whether this cosmic force could be an engineered phenomenon. If an advanced civilization possessed technology far beyond our understanding, could they manipulate such large-scale structures? This possibility, though speculative, opens a realm of thought where extraterrestrial intelligence might operate on levels we cannot yet comprehend. Even the peculiar dimming patterns of Tabby's star have drawn attention from those exploring alien megastructures. The star's irregular light fluctuations defy natural explanations, leading some to hypothesize the existence of a Dyson sphere, an enormous energy-harnessing construct theoretically built by an advanced civilization. While there is no direct evidence to confirm this, the very notion challenges us to think about what alien ingenuity could achieve. Could rogue planets drifting silently through the void be remnants of alien systems cast out by unimaginable cosmic dramas? Or might these orphaned worlds even harbor life, equipped with internal heat sources that could sustain biology in the absence of a nearby sun? Similarly, the ultra-diffuse galaxies, with their puzzling extremes of dark matter presence or absence, might hint at unknown forces or interventions orchestrated by intelligent life forms. As speculative as these ideas may seem, they compel us to consider the profound possibility that humanity is not alone in the universe. What if some of the universe's greatest mysteries, the very phenomena that defy explanation, are subtle whispers of civilizations beyond our reach? These questions deepen our curiosity and fuel our determination to explore further, because if extraterrestrial influences are indeed woven into these cosmic puzzles, understanding them could redefine our very existence. With these profound possibilities in mind, it becomes equally essential to acknowledge the challenges scientists face in uncovering the truth hidden within the depths of space. As the next challenge unfolds, it becomes clear that unraveling these cosmic mysteries is no easy feat for scientists. One of the most significant hurdles lies in the limitations of our observation tools. Despite groundbreaking advancements in telescopes and detection systems, our ability to study the universe is still constrained by the technology available. Many phenomena occur at wavelengths or intensities that our instruments cannot yet detect, leaving critical details hidden from view. Even the most sophisticated devices, like the James Webb Space Telescope, are only beginning to scratch the surface of what is out there. Another overwhelming challenge is the sheer vastness of space itself. Distances between celestial objects are so immense that even light, traveling at nearly 300,000 kilometers per second, takes years or centuries to bridge the gaps. This vast scale means that by the time we detect signals or observe cosmic events, they often represent occurrences from millions or even billions of years ago. Attempting to infer present-day dynamics from ancient evidence is like trying to guess the contents of a sealed book based on its heavily worn cover. And then there is the sheer complexity of space. The universe operates with laws and phenomena that are often counterintuitive or entirely unknown to us. Concepts like dark matter and dark energy, which remain largely theoretical, illustrate how much of the cosmos we cannot yet explain. Many observed anomalies, whether it is the behavior of rogue planets or the peculiar structure of Saturn's hexagonal storm, pose questions that current scientific models are unable to answer. It is these unknowns that continually push the boundaries of human understanding. Together, these challenges create a formidable barrier to solving the mysteries of space. Yet, it is precisely these obstacles that inspire innovation and fuel our determination to keep exploring. As we develop better technologies, refine our theories, and expand our reach into the cosmos, each small breakthrough brings us closer to unlocking the secrets of the universe. Moving forward, it is worth exploring why these unsolved mysteries matter, not only to science but to humanity's place in the grand cosmic story. Moving forward, let us delve into why these space mysteries truly matter, both from a scientific and a philosophical perspective. At their core, these unresolved phenomena serve as powerful reminders of how little we truly know about the universe. Each unanswered question represents an opportunity, a doorway to discovery that could fundamentally transform our understanding of reality. From a scientific standpoint, these mysteries push the boundaries of what we think is possible. They inspire the development of advanced technologies like more sensitive telescopes and faster computational models to seek out the answers hidden in the vast reaches of space. The pursuit of these answers often leads to innovations that ripple far beyond astronomy, influencing fields such as medicine, engineering, and even our everyday lives. But the significance of these enigmas is not purely technical. On a deeper, more existential level, they challenge us to contemplate our place in the cosmos. When we look at phenomena like the Great Attractor or the Boötes Void, we are forced to confront the sheer scale of the universe and the humbling reality of our relative insignificance. Yet, far from discouraging, this realization fuels a profound sense of wonder and curiosity. It sparks questions that have driven humanity since the dawn of time. Are we alone in the universe? What forces shape the galaxies, stars, and planets we see today? And perhaps most intriguingly, what lies beyond the edges of our comprehension? These mysteries also unify us as a species. The quest to understand the cosmos transcends borders, languages, and cultures, reminding us that we are all part of the same vast and interconnected universe. In pursuing answers to these cosmic puzzles, humanity is not just searching for knowledge, we are seeking meaning, connection, and a deeper understanding of ourselves. Ultimately, space mysteries matter because they embody both the limits of our knowledge and the boundless potential of our curiosity. They are the unanswered questions that drive us to dream bigger, think deeper, and explore further. As we unravel the secrets of the cosmos, we are not only learning about stars and galaxies, we are uncovering the infinite possibilities of what it means to be human. Now turning to the conclusion, throughout this journey, we have explored 20 of the most perplexing mysteries that space has to offer, each one a testament to the vastness and complexity of the universe. From the enigmatic pull of the Great Attractor to the ghostly whispers of fast radio bursts, from the puzzling absence of matter in the Boötes Void to the shimmering enigmas of rogue planets and ultra-diffuse galaxies, these phenomena remind us of how much we have yet to uncover. The unresolved questions surrounding dark matter, dark energy, and the very shape of the universe itself invite us to dream bigger and reach further. We have seen how gamma-ray bursts, Saturn's hexagonal storm, and even the unlikely anomaly of the Pioneer spacecraft reveal a universe that is as mysterious as it is awe-inspiring. Yet, through all this exploration, one thing remains clear. Space is more than a collection of stars, planets, and galaxies. It is a frontier that challenges our imagination, our science, and our very sense of existence. As we marvel at these cosmic enigmas, we recognize that they are not just puzzles for scientists to solve, but windows into the deeper questions that unite us as humans. What lies beyond the cosmic horizon? Are we alone in the universe? And what role do we play in this grand, interconnected tapestry of existence? These mysteries encourage us to look up, to question, to innovate, and to explore not only what is out there, but also what it means to live in a universe so boundless and extraordinary. So as we wrap up this odyssey through the cosmos, we invite you to share your thoughts. Which of these mysteries do you find the most fascinating? Are there any phenomena you have wondered about that we did not cover? Let us know in the comments, and don't forget to subscribe to our channel for more captivating journeys through the mysteries of space. Hit the like button if you enjoyed this exploration, and turn on the notification bell so you never miss our next adventure. Together, let us continue to gaze at the stars and seek answers to the questions that define us. The universe is vast, mysterious, and full of wonder, and our journey through it is only just beginning.